Greetings to each and every one of you, wherever you are. I do hope that you can join me in appreciating yet another beautiful and exciting episode. You are once welcome again to Prince D TV, and of course, you are equally welcome to Triumph with Prince D Maths. Today, as usual, we are going to dive into something fresh. So today we'll be looking at finding specific values of functions. I guess that sounds familiar, right? So we began with functions mapping, looking at the vertical line test, the range, codomain, and all of that. So we are moving into functions properly, how we can find specific values of given functions. That's it. So the value of a function or a specific function can always be calculated. So that value of a particular function can always be calculated. And of course, this involves substituting that value into the function, substituting that specific value into that function to find its value. However, this is only done through a mathematical know-how. So without wasting much of your time, let's get into the job. So we have our first beautiful example with us. So finding specific values of a function. So example 1, we now have a function which has been given. Example 1, if. So functions, they have a particular way that we usually read them. So this is the function. This is the function. Remember, functions are always denoted with lowercase letters. Small f, the most commonly used letters, we have F, G, and H. Remember, any other letter can be used, but I'm just reiterating that the most common used lowercase letters that are mostly common where we use to denote functions are often the F, G, and H. Remember, any other letter can be used. All right, so this is read as F. The two dots implies such that X, and the arrow implies maps or connects or is related to. So F such that X is mapped onto 2x minus 7. So that's the function. F such that X maps onto 2x minus 7. Now, question. Find f of 0, f of 2, f of 3, and of course f of -4. So this is what we are looking at today, finding specific values of a function. This is a function and these are the specific values. Okay, so f, we have f of 0, f of 2, right up to f of -4. F signifies that this is a function we are using, f. We cannot take another function, we only take the function that is representing this. So we'll just go straight. So we have how many examples here for case 1? 1, 2, 3, 4. All right, so let's start with f of 0. So when you have a specific value and you have to look for it, like we said earlier, you substitute that specific value. Our first specific value is what? Is 0. The value that has been given here. We have to substitute it into that function. Remember, this function f such that x maps onto 2x minus 7, it can be written in a more concise or plain manner. So I'll repeat it again. F such that x maps onto 2x minus 7. It is the same as f of x is equal to 2x minus 7. That's the first step. So this is the way we normally interpret it. From here, we can now look for the other values that have been given, or which have been given to us, to look for their specific values. So you now notice that f of x is same as f of 0. So wherever we meet an x, or wherever we see an x, we substitute that particular value in the place of that x. So we are substituting. We remove x and we replace x by that value. All right. So f of 0, we take the first one, f of 0. So in every case, this is the way you do it. First of all, you look at your function, then you interchange. Okay. So our first is f of 0. Anywhere I see x, I replace it with the 0. We are starting with 0. So if I'm to look for f of 2, anywhere I meet x, I replace it with 2. But in this case, I'm starting with 0. So I replace f of 0 is equal to, so I'm replacing, or everywhere I meet x, I replace it with 0. That's the rule. Simple. 2 into, remember it is multiplication. That's why I'm putting the brackets. All right. It will not always be, it depends on the way the function appears. So 2 into 0 minus 7. So we are looking for a specific value of this f of 0, of these values that have been given. So this is equal to, now multiplication, 2 multiplied by 0, or 2 times 0. It is 0. Remember, anything multiplied by 0 is 0. So we have 0, our minus is left, and our 7 is there, which is equal to 0 minus 7. Remember our number line, 0 minus 7. 0 minus, we are moving towards the left. How many times? 7 times. So our result is negative 7. So f of 0 is equal to negative 7. We are done. So that is exactly the same procedure we have to follow for the rest. Okay, the same we have to follow for f of 2, the same we have to follow for f of 3, and of course the same we have to follow for f of negative 4. Now in this case, since we have done f of 0, the same thing with f of 2, the same thing with f of 3, I would like to just jump straight away in for f of negative 4, which is a negative. So let's see how we can manage the negative sign. All right. So that said, from here, I think we can use this space. So here, f of negative 4 is equal to 2. Wherever I meet x, I replace it by the value I'm using, that is negative 4 minus 7. Minus 7. Which is equal to, now, 2 multiplied by negative 4. Now, the reason why I decided to choose it is because I know there is a negative value. And one thing we have realized is that many students, or many enthusiasts of mathematics, often get a little confused when it comes to the negative signs. But for everything there must be a solution to take care of that. There is a proper way to manage it. And that is, of course, why in previous sessions I gave you some rules. Positive, the final result to take is positive. Positive, negative, the final result is negative, and so on. So you realize, you ask yourself, this our number outside 2 is a positive 2. Remember I told you positive 2 is same as 2. For positive, the positive must not be written in front. But if it is a negative, the negative must be there. All right? Good. So our 2 is positive, and the 4 inside is attached with a negative. So obviously we have positive, negative. So we ask positive, negative, what is our final result? Remember the rules I gave you, the final result is negative. So you notice now that the +2 and the -4, the final sign will be a negative sign. So you see that we have managed the negative sign there, and we are left with 2 multiplied by 4. 2 multiplied by 4 is 8, and of course there is a negative here in front of the 7, and there is a 7 there. Now -8 minus 7, of course, using our number line again, -8. Okay, -8 on the left hand side of the number line. Minus indicates we are moving to the left. How many times? 7 times. And when we do that, you will realize that our result is -15. All right, -15. And what does that tell you? It tells you that so f of -4 is equal to -15. So that's the specific value of f of -4. All right, good. And that's it. But before we conclude, I would like us to look at a few other examples where maybe the function is having a fraction or is having something like a square root sign. And when we brush that, and I'll be fully, confident, to tell you that now you can be able to trash whatever concerns finding specific values of functions. Okay, so without wasting much time, let's jump into that right away. Welcome back once again. So just like we mentioned earlier, now it's still the same stuff, same functions and beginning, but you realize something. These are not just maybe linear straight functions as well. Now I've involved functions that have maybe square roots and those that maybe have something like a fraction. So with that said, I just want us to brush everything. So we notice that for this example too, we have 2 different functions, a and b, and the first function is g such that x maps onto the square root of x plus 1. G such that x maps onto the square root of x plus 1. So let's begin with g first before we get into the, or we can still read it, no issues. For b, this function is being denoted with letter j. J such that x maps onto x minus 1 divided by 2 or all over 2. G such that x maps onto x minus 1 all over 2. Let's start with A. A, they have asked us to find g of 2 and g of 3. Remember our function g, it can be written as, like we said in the previous example, g of x is equal to this. It's equal to the square root of x plus 1. Remember, that's how that our function can be represented. All right, that's how it can be represented. Now, so the first is g of 2. So g of 2 is equal to, anywhere we meet x, we replace it with 2. Remember our square root sign, the square root of, there is x, our x now we replace it with 2 plus 1. Are we there? Yes, of course. Equal to the square root of, what is 2 plus 1? 3. So root 3. Now, like I always say, in a case like this, when they start to ask you maybe in 2 decimal places, place values, and they start to ask you stuff like that, you will go further. Okay, but it is very much okay to leave it like this. So g of 2 is equal to root 3, which is very much okay. Now we are ending it like that. In a case, let's say our value inside was maybe 4. Now we can have an exact, a perfect square, right? So we can have an exact. So if it was 4, now the square root of 4 is 2. So now our answer will finally be 2. But there's no perfect square here for 3. So we can leave it like that. Other than the fact that maybe we can go and start to have some points. But here it is very much okay. And secondly, we have g of 3. G of 3. So let's continue. I think I'll put it like this. All right, let me just take it all over. So g of x is still our function. So g of 3, the last one under the function g of 3 is equal to the square root of x. We replace it with 3 plus 1. Already we are having a 4 here, what I was trying to explain before. So we now have the square root of 3 plus 1, 4. And what's the square root of 4? So this sign simply means square root. So the square root sign, it means the number under this square root sign. So this means square root, which means 2 times. So which number you will multiply? So this sign means which number are you going to multiply to itself twice that will give you this number under the square root sign. So to put it in a more better perfect condition, which number are you going to multiply to itself twice that will give you 4? That's exactly the meaning. So it is, you and I, we already know that the square root of 4 is 2, right? We know that the square root of 4 is 2. But I just want to show you how we are coming about with the 2 under the square root sign. So this means 4. Which number do we multiply to itself twice that will give us 4? It is 2 times 2. Are we there? Now I told you this sign means 2. Square root, it means 2 times. All right, so this square root sign can cancel with one of these 2, and what are we left with? Just a 2 which is left, and that's why we always have the square root of 4 is 2. Are we okay? Good. And lastly, let's look at the other function, which is having some fractions. Still the same procedure, nothing has changed absolutely. So let's dive in and round up. All right, Prince D TV fam, I hope everything is going smoothly by now. All right, so our j of x, so we can, j of x is equal to x minus 1 over 2. That's how we always represent it. Okay, good. Our first is j of minus 1. So j of minus 1 is equal to, anywhere we meet x, we replace it by minus 1, the value. So, you know, not in every case they will always use x. They can change the letters. Like I always tell you, x is just that a more convenient letter, an arbitrary symbol which does not have a specific meaning on its own. So simple to use, very easy to recall and to master. That is why in most cases they often use an x. But that does not dispute the fact that it can't be changed. So note, mind you, you can meet an M, a P, a Q, a D, a Z, and so on. You can name the rest. But for sure, do not be confused, because it can change at any time. All right, thank you so much. So j of negative 1, we replace our x with negative 1, and we have a negative 1 behind, divided by 2. Number line has come in, negative 1 minus 1. Negative 1 is in the left part of the number line. Negative signifies I'm moving to the left how many times? 1 time. So negative 1 minus 1 is simply negative 2. And we are dividing by 2. What do you notice? Our negative sign, still the rules. Our 2 here is positive. So it means we have a negative divided by a positive. And what does that tell us? I told you the negative is always powerful, right? Negative, positive. So it is a negative that is remaining. 2 here and this can cancel here. 1, 1. So 1 divided by 1 is 1. So our answer there is simply negative 1. Are we together? Yes. And we're about to round up the last one, which is of course J of 3. Okay? J of 3. Alright, so we are going to do that without wasting so J of x is equal to x minus 1 over 2. So J of 3 is equal to, we are replacing the x with 3. 3, we have minus 1, then all over 2. The 3 is positive, no negative. So it's easy. 3 minus 1 is obviously 2. All over 2. Oh, so 2 divided by 2 is 1. Unlike the previous one, J of negative 1, the answer was negative 1. So that brings us to the end of this beautiful episode, which was, titled Finding Specific Values of a Function. Prince D TV fam, thank you so much. I really appreciate you for sticking right up to the end of this prestigious episode and of course a tutorial. Urge you to always stay connected, be updated, make sure you comment, you like, you share to somebody who might find this helpful in one way or the other, and of course we'll be there to serve you with some outstanding, much more beautiful content. Thank you so much. As you already know, I remain your boy, Prince D. Much love and God bless.